Okay, folks, hello. Welcome to week 3 of off-site learning. So this week we are going to jump into the third and final kind of section of our chemistry unit. For that, you will need booklet 3. Okay, this is posted on Google Classroom. It looks like this. This section is all about organic chemistry and looking at hydrocarbons. So we'll jump right into it. Okay, so what is organic chemistry? Well, to think about that, let's break down that word organic a bit, okay? So you might kind of connect that organic to maybe a word you've heard before in science class, and that is organisms. And so the connection between organic chemistry and organisms is the chemistry that we are talking about has to do a lot with life, okay? So what kind of chemistry is that? Well, it has to do with carbon, okay? So carbon is the building block of all biological, bio meaning life, in biology you study living things, okay, of all biological compounds. In other words, compounds that are in living things, okay? So since most of these contain carbon, a lot of the molecules containing carbon are called organic molecules, like organism. You would find them in living organisms, okay? So organic molecules are found in all kinds of things, not just living things. We also find them or make them for food, medicine, plastics, and one of the big ones is fossil fuels. Organic chemistry is huge for the fossil fuel industry. Okay. So, like I said, we're going to be dealing a lot in our organic chemistry here with the study of something called hydrocarbons. Can you guess from that word what two kinds of elements are going to be involved in hydrocarbons? Well, you've got hydro and you've got carbons. So, you guessed it, hydrocarbons contain hydrogen and carbon only. Okay, so nothing else. It's just hydrogens and carbons stuck together. Okay, so what what a lot of organic chemistry is studying the structure of hydrocarbons, how they're put together. So just to kind of think about the structure of hydrocarbons, we're going to start by reminding ourselves of Lewis dot diagrams. Okay, so a Lewis dot diagram, it asks us here to do it for methane or for CH4. Now, we don't know yet why methane is called CH4, but after this section, we will. We would be able to hear the word methane and know exactly what it looks like. Okay, so let's start with the Lewis diagram. So it's got C and 4 H's. So let's start with the C. Now, how do we tell how many valence electrons, because those are going to be the dots on our Lewis diagram, how do we tell how many carbon's going to have? Well, remember, it's the last digit of the element's group number on the periodic table. So carbon is in group 14. So the last digit of 14 is 4. So it's going to have 1, 2, 3, 4 valence electrons. Remember, those valence electrons, those lonely ones, those are the ones available for bonding, right? They're lonely, so they're available to make bonds. Okay, a little bit of a side note on why did carbon end up becoming the building block of life? Well, I want you to think about this. If carbon had one more valence electron, if it had 5, let's say, okay, 5, well, now these aren't able to bond anymore. So it actually only is available to make 3 bonds. Okay, that's if it had one more. What if it had one less valence electrons? If it had only 3 valence electrons? Well, again, there's nothing here to even bond with, so it has 1 lonely, 2 lonely, 3 lonely valence electrons. So now it would only be, again, able to make 3 bonds. So pretty much the maximum number of bonds an atom can make is 4, right? So carbon has that. So carbon is kind of the best Lego piece it could possibly be. It's available to make the maximum number of bonds. So that's why it's no accident that carbon became the building block of life. There was carbon floating around, and when life started to be kind of put together and start to evolve, right, it chose carbon, so to speak, because it was the perfect way to build stuff. It was the most efficient builder. Okay, let's now get back to making methane, CH4. So we know what is carbon trying to do? It's trying to have 8 valence electrons total. Right now it's got 4. So carbon and hydrogen are both non-metals. So everything we deal with in this unit is going to be a molecular compound. Now remember, what's the difference between a molecular compound and an ionic compound in terms of electrons? Well, they share them instead of transferring them, right? So hydrogen is in group 1. That's why I gave it 1 valence electron. Hydrogen wants to have a full shell. For hydrogen, a full shell is just 2, right? Because hydrogen is in that first energy level where a full shell would just be to fill this one, right? Remember the 2882 rule? So 2 would actually be full. So hydrogen has this 1 electron. It's going to share that 1 electron, and there we go. Hydrogen's actually happy. It's full. It's got 1, 2. Hydrogen is full. So what can we do? Well, we bring another hydrogen in because carbon only has 1, 2, 3, 4, 5, right? So carbon is not happy yet. It wants to have 8 total. So we'll bring in another hydrogen. No worries. Okay, those ones can share. Now carbon has 1, 2, 3, 4, 5, 6. We're getting there. Okay, maybe you can see where this is going. So we bring another hydrogen, and carbon now has 1, 2, 3, 4, 5, 6, 7, but one more would make it happy. So what about one more hydrogen? And they can share those electrons. And there we go. Every hydrogen is happy. It's got 1, 2, and carbon is now happy because it's got 1, 2, 3, 4, 5, 6, 7, 8 valence electrons and a full outer shell. Okay, so looking at this Lewis dot diagram, I'm now going to draw something that you haven't seen before, but it's going to look real familiar, okay? Because what is a structural diagram? Well, here it is. Here's the structural diagram for methane, CH4. Look familiar? Right? It's essentially the Lewis dot diagram without the dots. So because structural diagrams almost always deal with just hydrocarbons that we're going to be drawing, right, in our organic chemistry section, well, we know that carbon is always going to make 4 bonds. We know that hydrogen is always going to make 1. So we just say, do we really need to draw the dots every time? Or can we just have carbon make 4 bonds, have hydrogen make 1 bond, and then just call it a day, kind of, right? So that is kind of where we're going with this. We're going to be essentially drawing Lewis dot diagrams and then dropping the dots and just calling it a structural diagram, because we know that carbon always can form up to 4 covalent bonds, okay, where electrons are shared. Don't forget that's what covalent means, basically molecular. Okay, hydrogen can form only 1 single bond. It only has 1 electron to share anyway. Now, here's an important idea. The idea of saturated hydrocarbons versus unsaturated hydrocarbons, okay? So a saturated hydrocarbon have only single carbon-to-carbon bonds, okay? So they'll only have 1 carbon bonded once to another carbon. So every carbon will only be bonded once to another carbon, as opposed to twice or 3 times to another carbon, okay? So this means that the maximum number of hydrogen atoms that could possibly fit on there are going to be used, because they're going to fill in to make every carbon happy, right? Hydrogens are going to fill in the gaps where the carbons are looking to share more electrons. So it contains as many hydrogen atoms as could possibly fit. Okay, so that word saturated, right? Saturated, if something is saturated, it means it's full, right? It couldn't fit anymore. Like if you have a saturated sponge, it's completely full of water. You can't fit any more water into it. That's what saturated means. So when we're talking about saturated, we kind of mean saturated with hydrogen. So let's just say saturated means full of hydrogen. It's got as much hydrogen as you could possibly fit into it. All right, unsaturated hydrocarbons, what do you think that means? It means it's not full of hydrogens, okay? So essentially, we could fit more hydrogens if we broke a double or triple bond. And again, you might not know what this stuff means yet. That's okay, we're going to get to it, but I just want to get these definitions out of the way. So if we were to break a double or triple bond, then we might be able to fit some more hydrogens on there. Okay, so unsaturated hydrocarbons have at least 1 double or triple carbon-to-carbon bond, okay? Which just means that more hydrogen atoms could fit if those double or triple bonds were broken. So just a little trick to remember this, okay? Because essentially what it boils down to is that if it's saturated, it only has single bonds. If it's unsaturated, it means there's at least 1 double or triple bond, okay? So how I remember it is saturated equals single bonds only. What does saturated start with? An S. What does single start with? An S. So if it's saturated, it only has single bonds, okay? Just to give you a quick visual of what this looks like, here are 2 very similar hydrocarbons, okay? One is going to be saturated, one is going to be unsaturated. Notice they both have 2 carbons, okay? But the difference is, do you see it? How many double bonds are there here? Do you see any time carbon is bonded to another carbon more than once? I don't, right? Look, only a single bond. The only time a carbon is bonded to a carbon is with a single bond, right? But look down here. There are 2 bonds here between just these 2 carbons. They are bonded to each other twice. That's called a double bond, okay? Now notice this one has 1, 2, 3, 4, 5, 6 hydrogens. This one only has 1, 2, 3, 4. That's because this bond here could have gone to making 2 more hydrogens, right? But it's not. It's kind of being, you can think of it as being wasted on a double bond, okay? So this is saturated with hydrogens. There's no way to fit any more hydrogens on there, right? Where are you going to put them? Both carbons are already making 4 bonds, and there's no bond we could kind of break and squeeze some more hydrogens in here. Whereas here, if in theory we broke that double bond, well, now we have room for two more hydrogens. So this is not full of hydrogens. It is unsaturated. So like I said, carbon is the perfect Lego piece, right? It's really cool. Carbon can make a bunch of really awesome bond shapes. So because it can, many different molecular structures can form, including unbranched chains, branched chains, and rings, okay? So, but in Science 20, we're only gonna look at branched and unbranched chains. So what does it look like? It's gonna start to look like these guys, okay? So these are our chains. These are our branched chains. Notice how this just like looks like one continuous chain, right? It's kind of just one long pathway of carbons. This one has an oxygen, which we're not going to deal with, but you can put them in there. Notice how this one kind of has the main chain, like the main road, and then a little side road, a little pathway off where. We call that a branch. It's like the trunk of the tree in a little branch. We are going to deal with those, not in this topic, but in the next topic. So that is actually going to wrap up our topic one, which is just looking at a kind of a general introduction to hydrocarbons and organic chemistry and the idea of saturated versus unsaturated, okay? So it's called organic chemistry because it looks at these molecules that are the building blocks of life, right? Hydrocarbons, okay? Organic as in organism, living organisms, okay? So these are found in living organisms and other stuff too, but a lot of them begin in a living organism. For example, a lot of them are fossil fuels, right? So fossils used to be alive, right? A long time ago, okay? Then we got into the difference of saturated versus unsaturated. So saturated, single bonds only, right? S and S. Saturated means full, and what are we saying it's full of? It's full of hydrogens. It contains as many hydrogens as it possibly could. There's no other way to fit another hydrogen on here because every carbon is full, right? Here, every carbon is full, but we kind of think of it as it doesn't have as many hydrogens as it possibly could, because if we broke that double bond, for example, then we would have room for two more hydrogens. So this is unsaturated. Okay, so saturated means single bonds only. Unsaturated would mean at least one double or triple bond. So for some practice, you can now actually try the beginning part of the formative work for this week. Okay, just looking at differentiating between a hydrocarbon that would be saturated and one that would be considered unsaturated.